Okay, hello. So this is the first video to help students with their GCSE science. So you need an exercise book. So let's just get you one of those. In fact, if you get one from the back corner. Okay. So we're going to start off with atomic structure. And the periodic table. And each week we're going to go through different parts of the course. So here we've got what's called the exam specification, and this tells you every single thing that you need to know for your GCSEs. So if anybody wants a copy of this, then they're welcome to come and see me and I'll give them a copy. So I'm going to go through the first part, but by your exams I would have gone through all the different parts of the course. Okay, so to start with, if we're talking about atomic structure, we need to know about the atom. So this is the smallest part of an element. Okay, so we're just concentrating on exactly what you need to know for the exams. And a compound, which you may have heard of, contains two or more elements chemically bonded. Okay, so an atom is the smallest part of an element, and a compound contains two or more elements chemically bonded. You need to learn those definitions off by heart. So if we do a little bit of practice and I write oxygen, oxygen is written as O2. You need to know for your exams why it is O2, and that's because oxygen's a non-metal and it bonds covalently and it needs to share a pair of electrons, but for now O2, and that contains two atoms, because the small number tells you that you've got two oxygen atoms bonded together. That is not a compound, so it's not a compound because it hasn't got two or more elements bonded together, because they need to be different, which I should have mentioned before. Okay, so these are the same, so therefore it can't be a compound. If we look at methane, then methane is written as CH and a little 4. Now that means you've got one carbon and you've got 4 hydrogens covalently bonded to that carbon. So there you've got 5 atoms, because you've got one carbon and you've got 4 hydrogens around it. Again, that wouldn't be called a compound. If we look at a different one now, so if we look at what's called a mixture, then that is 2 or more elements or compounds, but this time they are not chemically bonded. Okay, so a mixture is 2 or more elements or compounds not chemically bonded together. Now you need to know how to separate a mixture. So I've got a few people listening to me now, so can either of you tell me how we can separate a mixture? So you could use filtration. What else could you use?
Crystallization.
Very good. So you could use crystallization. Anything else? Boiling is just the process by which something reaches its boiling point. So that
Evaporated.
See, I suppose evaporation, yeah, you could have, but it's not on my list, so you can't have it.
Oh.
You could have distillation. And you could have, what's the one called where you separate the inks? Might not have done it yet. Chromatography. Okay, so they're the four. Oh, and there's another one as well. Fractional distillation. Okay, so they're the ones the exam spec says that you need to learn. So can you give an example where you might use these separation techniques for filtration?
If you time traveled back in time and you want to have clean water.
Yeah, good. So you could also use sand and water. Distillation is where you would purify water. Right, so that's an important one. So if you've got there, so if I just make a little link to that one, if you've got in this conical flask here, you've got basically dirty water. What would you have to do to that dirty water to make pure water? So there's the dirty water. So it's not pure because it's got other things in it other than water. What would you do to it?
So you could move it through the filter.
So it's all sort of dissolved into it. So what you have to do is you have to heat it first and you have to condense it. And if you heat it at 100 degrees C, you'll find that the water will start to boil and the water will then condense. And in here, you will start to see pure water forming. And all those other horrible things that were in the dirty water will stay there. So that's how you can purify water. Is that all right?
Yeah.
Okay. Next bit is the developing, let me change the pen, the developing model of the atom. Okay, so developing model of the atom. So for that, you need to know that back in time, or not really back in time, but originally they thought that atoms were tiny spheres. So atoms were tiny spheres that could not be divided. And that was hundreds of years ago. That's what people thought the atom originally was. And that was before they discovered anything like protons, neutrons, electrons, the nucleus. Then, what was that? That's meant to be an arrow. Then, they discovered the electron. So that obviously made people think, well, hang on a minute, so perhaps there's more to it than just a sphere. So they came up with the idea of the plum pudding model. So the plum pudding model. And that was effectively a circle, and it had areas of negative charge, which were the electrons, but it was all in a positive area. So you'd refer to that as a ball of positive charge. So a ball of positive charge with negative electrons in it. Okay, so that's the plum pudding model. So it's a ball of positive charge with negative electrons in it. Okay, then they kept experimenting, and Ernest Rutherford and his students at Manchester University then did what's called a very famous alpha scattering experiment. Okay, the alpha scattering experiment. And this is effectively where he got some gold foil. So there's the gold foil. And he fired alpha particles at it. And alpha particles have a positive charge. So if we imagine the gold foil to be made of lots of atoms, so he's firing the alpha particles at these atoms, and most of them went straight through. So they realised, number one, the atom, mostly empty space. Because when they were firing these alpha particles at it, they were going straight through. However, the big discovery was that some of these alpha particles bounced back. And that was an amazing result for an experiment, because that showed that there was a nucleus. There was something in the middle. They also found that ones that got quite close to the middle got deflected. And that deflection told you that the nucleus was positive, because the alpha particles were positive and they were being repelled by the positive nucleus. So as you can see, over time, originally tiny spheres that could not be divided, then they discovered the electron. That led to the plum pudding model. Then Ernest Rutherford looked at the plum pudding model. He fired particles at it, alpha particles. Most went straight through, but he noticed that some got deflected, so he realised that there must be a nucleus there, and the plum pudding didn't show a nucleus. Then, as other scientists then looked at it, Niels Bohr then adapted the model to say that the electrons orbit the nucleus. So they go around the nucleus in shells. So Niels Bohr then added shells to the model. So orbit the nucleus in shells. And then James Chadwick discovered, lads, do you know what he discovered? The neutron. And then obviously science is still taking place, looking further and further into the atom. Now, you need to know about the subatomic particles. What are the subatomic particles? The particles that are inside an atom. What are they called?
Protons, neutrons, and electrons.
So you've got a proton, you've got a neutron, and you've got an electron. So where would you find the protons? So protons are in the nucleus. Where would you find the neutrons?
Also
In the nucleus. Where would you find the electrons?
orbiting the nucleus.
Good. In shells orbiting the nucleus. What charge has a proton got? So positive. What charge has a neutron got?
Neutral.
Neutral, or we'd say no charge. And what charge has an electron got?
Negative.
negative. And what is the mass of a proton?
1.
Yeah, we say plus 1 atomic mass unit. A neutron?
Plus 1.
+1, and an electron
Negligible.
is negligible. It's very, very small, so we say almost 0. It's actually 1 over 1,838, so it's incredibly small if you did that on your calculator, but not minus, almost 0. Okay, so if we look at an atom, and on your periodic table that you get given in the exam, this shows all of the different atoms. So if we look at the element iron, then iron contains just iron atoms, and each iron atom has an atomic number of 26 and a mass number of 56. So if we choose an atom, say lithium, okay, lithium's got a 7 and a 3. So 7, 3, lithium. So we need to work out how many protons, neutrons, and electrons there are in lithium. So how many protons have we got? Any ideas?
3.
Good. The protons is always the bottom number, the smallest number, which is 3. How many neutrons have we got?
4.
That's the top number minus the bottom number. So that's 4. Good. So to get that, I've done 7 minus 3. And how many electrons are there? 3. Because the number of electrons is always the same as protons. So in an atom, the number of protons equals the number of electrons. Okay, and that can cause a little bit of confusion. So if I just show you again, 7,3Li, it's got protons, and we said that it's got 3 protons, and we know that protons are positive, so it's got 3 positive protons. We've worked out that it's got electrons that are 3, and we know that electrons are negative, so it's got 3 negative electrons, so that's electrons. And it's got neutrons, which don't have any charge, so I won't show them at all. But you can see that by having exactly the same number of protons and electrons, they cancel each other out. So that's why atoms always have exactly the same number of protons and electrons. Now, if we look finally for today at ions, that means an atom which has lost or gained electrons. An atom which has lost or gained electrons. So if I did an atom of lithium, which we know is 7 over 3 Li, and if we know before that if we look at the number of protons, we said that it has 1, 2, 3. Electrons, we said that it had 1, 2, and 3. Now, if it was to lose an electron, so if it lost that electron, then that would cancel with that would cancel with that, but that plus would be left on its own. So we would call it 7 over 3 Li. And that is an ion that has lost 1 electron. So it's now got 3 protons, 4 neutrons, but it's lost 1 of its electrons. So it's now got 2 electrons. Okay, so an ion is an atom which has lost or gained electrons. So if I just do a quick recap of what we've said today. We've said that an atom is the smallest part of an element. So these are all the elements on the periodic table, and so iron contains iron atoms, magnesium contains magnesium atoms. A compound is different elements chemically combined. So that's not a compound. That's not a compound because they're not different. But we can see that oxygen's got 2 atoms, methane has got 5 atoms. A mixture is elements or compounds that are not chemically bonded, and you can separate them. And these are the 5 methods of separation that you need to learn. Distillation can be used to purify water. Here's an example of distillation. It involves evaporation. So distillation always involves evaporation followed by condensation. And that helps remembering that. So distillation involves evaporation, then condensation. Chromatography is what you might have used once upon a time to separate the different colours in inks. And fractional distillation can be used to separate oil. So that's separating the different hydrocarbons in crude oil. We then looked at developing the model of the atom. So originally, we thought that atoms were tiny spheres that could not be separated. Then they started to do scientific experiments and they discovered the electron. Once they discovered the electron, they developed the model of the atom and they came up with what's called the plum pudding model, which is a ball of positive charge with negative electrons in it. Then Rutherford and his team did the alpha scattering experiment. So the model in place was the plum pudding model. They were looking to see if they could improve on that. They found that when they fired alpha particles into the atoms, some bounced back and that told them that there was a nucleus, and some were deflected and that told them that the nucleus was positive because the alpha particles were positive, so therefore they were repelling. So the alpha scattering experiment came up with the atoms are mostly empty space. It has a nucleus which is positive. Then Niels Bohr discovered that electrons actually orbit the nucleus and they're not just in fixed positions as shown there. And then James Chadwick discovered the neutron as we looked in more detail at the nucleus. We then said that things that you just have to learn. Subatomic particles, protons, neutrons, electrons. It's important to know where they are, their charge and their mass. And then it's important to know the difference between an atom and an ion. In an atom, the number of electrons is always the same as the number of protons. In an ion, it means either electrons have been lost or gained. If it's got a positive charge, electrons have been lost. If it's got a negative charge, electrons have been gained.